Hello guys and welcome to the channel. If you're new, drop a like, leave a comment, subscribe if you're new. If you haven't already, you know what to do. Without further ado, let's get into today's topic, which is numbers. What are numbers? So the first set of numbers I'm going to look at, which is sort of just a recap, is whole numbers. Which is represented by the symbol W. So whole numbers are basically numbers that fall in the set of 0 to infinity in the interval of 1, which means that if I go and I count these values in their set, I would start at 0, 1, 2, 3, all the way to infinity. Right. The next set of numbers is natural numbers. Natural numbers. And this cookie is starting to dry out. So what are natural numbers? Very similar to whole numbers, they are a set of values that start at one specific value, ends at another specific value within the interval of 1. Again, they start at 1 to infinity in the interval of 1. Now, a good way to remember the difference between whole numbers and natural numbers is you look at the O in whole numbers. And remember, okay, well, the O represents the 0, so whole numbers start at 0. Natural numbers start at 1. So again, if I were to count in natural numbers, I would start at 1, 2, 3, all the way to infinity, which is just never ending. It just means that the set never ends. Starts at 1, but never ends. The next set of numbers, which you should be quite familiar with, is integers. So what are integers? They're represented by the symbol Z. Now integers are very similar to whole numbers and natural numbers alike. Only difference is that the set that they fall in starts at negative infinity to infinity, again in the interval of 1. So how do I represent them? I represent them on a number line, which starts at negative infinity, ends at infinity, its middle point is 0. To the right of the number line, I have 1, 2, 3. To the left of the number line, I have negative 1, negative 2, negative 3. One thing you just should always remember about negative values is that they get smaller as they get bigger, or a more intuitive way of understanding it is that numbers, doesn't matter where you start on the number line, to the right they get bigger, to the left they get smaller. And that is basically it that you have to know for integers, natural numbers, and whole numbers. The new set of numbers that we're going to be talking about is rational numbers. So what are rational numbers? Well, the symbol that represents rational numbers is Q. But what are they? How do we represent them? Well, quite luckily we can represent them algebraically. So rational numbers are numbers that you can go and write as a fraction, and it would equal a rational number, provided that b is not equal to 0. Right? So when a denominator of a fraction is 0, that fraction then becomes undefined. Rational numbers, furthermore, are basically any type of number you can think of that you can write as a fraction, a whole number, natural number, and an integer. These are all rational numbers. So integers fall into the set of rational numbers, natural numbers fall into the set of integers and rational numbers, whole numbers fall into the set of natural, or actually natural falls into the set of whole falls into the set of integers, and integers into the set of rational numbers. Now this is something you don't particularly have to worry about now with sets. especially we'll cover that in a later topic, but that is it that you have to know for irrational values. So it is basically any value that can be written as a whole number, a decimal, a fraction, etc. The next number that we are going to look at, or set of numbers that we're going to look at, is irrational numbers. So irrational numbers is a Q prime. That's the symbol for it. So what are irrational numbers? Well, they are basically any values such as pi or non-terminating decimals. I should rather say other non-terminating decimals, because pi is a non-terminating decimal. So what the term non-terminating decimal means is that that specific decimal never ends. The values goes on and on and on and on forever to infinity. And not like the value in intervals goes on to infinity, but the decimal itself, it's how large that decimal is. It never ends. It's so large that it never ends. That is basically what irrational numbers are. But for this year, it's not something that you particularly have to worry about. You won't be working with irrational numbers very often, but you do in fact have to know what irrational numbers are. Hope you find this video helpful. If you did, leave a like, leave a comment, subscribe if you haven't already, and that is it for the video.